All right, I think we're ready to go. Okay, for the last panel or last session of the GOSIM conference, we have a panel discussion with the experts from today's sessions. I'll give a short introduction in case people have not been here. Sitting far, I guess, to my right would be Jonathan Kelly from the Diaxis Lab, Diaxis Framework. Next to him is Rick Ahrens for the MakePad. And then we have Martin Robinson from Servo Project. And then we have Eddie Burrell from also MakePad, one of the co-founders of MakePad. My name is Edward from FutureWay, along with Kevin Booth, also from Future Technologies. So if you're ready, we can get started on questions.
Sure. All right, let's kick this off with somewhat of a bland question. So in light of the topics we've discussed today, I want to know what parts of the Rust ecosystem, and be as specific as you want, do you think are missing as key parts of mobile and web development in Rust? You know, what would you like to see prioritized from other parts of the ecosystem, other members of the community, that would make your lives easier and the future of Rust on mobile and web better?
Well, I guess I can say this is a very personal perspective, but I feel like Rust, and probably in general, we lack a really good 2D path rasterizer. The things that are out there are like Skia, which is production ready, and there are a lot of other solutions, but none of them are really high quality enough to use in every case.
So 2D path rasterizer. Okay.
So coming back a little bit to the integration with mobile APIs, I would say that is definitely a missing piece for us. If that can be done in the spirit of low dependencies to zero dependencies, because talking to an FFI shouldn't require hundreds of thousands of lines of redundant Rust. It can be done, as we show with MakePad, in very few lines of code if you're specific about what you're going to use. Then yeah, I would love to have more components there to reuse, because it is an enormous job to try to bridge the gap there. The difficulty, of course, is that if you look at how Microsoft enabled its platform for the Rust ecosystem, is to dump a 360 megabyte chunk of Rust as a crate, which, to say the least, doesn't fit our lightweight definition of a compile time or a platform layer. So my question back would be, how do you balance the breadth of these APIs versus keeping it lightweight? Because that's going to be challenging.
It's definitely a challenge. So given that the Windows crate is an example of what not to do, do you think
in some ways, I mean, it is brilliant in many other ways, but the way it is shipped is not. Like, the only way I think this could be done is by looking at what you use in your code and then generating a custom crate that only imports the things that you need. That's the only path I see where you sort of reverse the way you bind to APIs.
Yeah, that's a great point. So some things David and I have spoken about may help address this. I know some other new functionality that Cargo wants to support, right? Like perhaps we could gate a bunch of things behind features and you could put it all in one crate, or you could have a meta-level crate that collects a series of many smaller crates, such that you would just be able to select in your build tree the crates that cover only the features that you need, something like that. That would also play nicely into the many small crates architecture. It's a tough question, but with future Cargo features, I think we could make this a little bit more ergonomic. For example, I know that I personally have wished for a better way to just define and select configuration spaces. This is a frequent complaint of mine. We could do that at the Cargo feature level, but then you have the issue of specifying default features and deactivating some of those. So I recall that Josh mentioned in his talk, I guess that was at a different the workshop, but Josh has mentioned the desire to support something like this in Cargo with deactivating specific default features, or having a global feature set. Just today, Ed Page of the Cargo team.
Microsoft actually has fairly granular feature selection, but the platform is so vast that even one feature is at least 30,000 lines of Rust, if not more. So what I've done for MakePad is I look at the specific symbols that you import from Rust and use that as a query selector on stripping the entire Windows crate for just those things. And then you get back down to only having 20,000 lines of Rust total imported. So yeah, if the platform is big, then features are not granular enough to limit the compile time. Because if I would only use the features from the Microsoft crate, I would still end up with like 60, 70 megabytes of Rust probably that I'd need to include, which is 70 times as much as when you strip it on the symbol basis.
Yeah, that's no good. I know one thing David and I had looked at, and this is very tentative, something like a form of static analysis.
Yeah, that's exactly what.
Okay, yeah, just to finish out the idea for those who aren't familiar, something where you're analyzing the code that is calling, it depends on some giant Windows crate, and you analyze the code to see exactly what dependency paths are traversed, and then filter out those ones and select them only for compilation. It's an open-ended problem. I know we had discussed this in the context of Android. I don't know to what degree it's possible, but that is something that we do want to explore. So perhaps that could be a way forward. It's hard to know for sure.
So I actually had a conversation with Josh about. Oh, sorry, is this better? Yeah. I had a conversation with Josh about this subject on a previous conference, and I think this is doable, but part of the reason it's difficult is because of monomorphization.
Oh, yeah.
So when you use a symbol, it's not immediately obvious which version of this function am I using, and then what are the dependencies. But I definitely think that is the way forward when it comes to dependency management. And also, referring back to your earlier question, what's missing from the ecosystem, I would really like to see a proper text rendering stack.
Oh,
which
I agree.
We currently don't have. Well, nowhere close.
You guys are probably the closest to that, so that could become you.
That might be true. That might be true.
Yeah. Okay. Any follow-ups? Any other answers? If not, we can move on. Okay. Edward?
My question is, are there any domains or specific areas of computing where you would not recommend using Rust as a language?
I may have an answer there. Possibly interpreters. The reason I'm saying that, in my experience, it's harder to write correct unsafe Rust code than it is to write unsafe C code. That's a little bit up for debate, but I think in general that's true. And when you do something low level, like writing interpreters or JIT engines, you almost, most of what you do is writing unsafe code. And I think something like Zig might actually be a better fit there. So that's one area I could think of.
Okay. Anybody else?
So one thing Rust is not very good at is ergonomic exploratory code, because you have to write unwraps on everything and handle all the exception cases, whereas when you're exploring, you kind of don't want to care about those things. So I've heard a lot of people say that they don't like using Rust for that. I also want to counter that in saying that once you move a little bit beyond that exploration and have to start refactoring or extending that code, immediately the benefit of Rust kicks back in. So where that barrier is between Rust being kind of in the way and actually helping you out, maybe in the order of a day of writing code or something, sometimes even a few hours. So it's not, it's there, but it's not, it is not as far away as people say they don't like code, Rust for code exploration is.
So one thing I've been discussing with Rick is we exclusively use Rust for MakePad right now. And so far we found that for low-level rendering, Rust is a great fit because it's a systems language. But once you start doing complex UI logic, that's where it becomes more painful. And I've been wondering, maybe we should have two layers here, where all the low-level stuff is done in Rust, but on top we have some kind of scripting language or something similar. I mean, this is a solution that people often arrive at, right? We're not the first to think about this. But yeah, I wonder, when you're dealing with high-level logic, where memory management is less of an issue, you can just use a garbage collector, whether there's something better suitable than Rust.
Oh, that's actually a great point. So not mentioned in my slides, but another part of this framework we're considering is something like a new embeddable scripting language that interops very nicely with Rust. JT has been working on one of these, but it's not ready for discussion yet. Do you feel like that would answer these claims and answer address these problems you have? And where specifically do you think it would benefit from that?
So, yeah, I've been talking to JT about this, and I'm very interested in his work. I think it could be a great fit. I mean, we would have to experiment with it. But like the benefit of his approach is that, well, it's essentially still Rust code you're writing, except, now it runs on a JIT engine. So you get all the benefits of dynamism there. So yeah, I think that's a very interesting approach, and it could work.
So, as a matter of principle, I try to postpone this moment as long as possible because I have been a victim of the JavaScript engine where you are sort of going into a scripting engine and fighting the barrier between the systems language and the scripting engine, because that is a very difficult to define what should be on what side of the barrier, right? So this is also what happened to Unreal. The script engine got so much code from the developers that they were losing so much effort optimizing the script engine itself that essentially they just chucked the whole thing and said, go write C++, because this is not doable. We do not know where the boundary is, and we're losing too much resources on the scripting engine.
So one reason I find JT's approach with Rise so interesting is that he's trying to eliminate that barrier by making the memory model of his scripting language compatible with the one that Rust already uses. And so then you don't have this issue of, well, like the scripting language uses one memory model, the native language uses another, and there needs to be some glue code in between. So once you have that problem, you need to decide where the barrier is, like Rick just said. So.
I feel like we're kind of just waiting for the right people to figure out the paradigms. So like there's, like, I don't know, there's two tracks that have to happen. One, like Rust itself has to evolve for the domains that it's working in. Things like async made it like a better language to do things like backend in, and UI to an extent. People need to figure out the paradigms that fit in the domains that Rust is currently not good at. And that's where we've been focusing with Dioxis. Is like it was state management first, because that's typically where you interact with writing apps. It's like renderer later, but state first. And I think a lot of the hooks stuff that have come out of Dioxis is like a lot better than a lot of the ways people were using, like doing state management in Rust apps. It's not perfect, and we're like trying to push the boundaries there, and some of it I think needs to be upstreamed into Rust itself. But a lot of the domains where you would say like Rust is not good today, I think just needs someone to figure out like the right APIs to make it fit.
Yeah, so an example of one of these cases that I've run into is it would be really nice if there was a better way to write build.rs code that wasn't so verbose, and maybe a scripting language that fit really well with Rust is in that vein somehow.
Okay, so I think it's good that a lot of the issues or the problem area that you were mentioning is sort of being worked on, or at least partially worked on by a lot of the people here, as well as some of the colleagues that we know of. So that's a positivity. So, okay.
Can I add just one more thing? So you just talked about we need to figure out the correct paradigm. Sorry, better?
Yeah.
So you just talked about we need to figure out the correct paradigms, and I largely agree. Rick and I have also been experimenting with different paradigms. Some of them, it's mostly data-oriented programming. I think that's what's a good fit for Rust in general. So we've been trying ECS-like approaches for our data. But to an extent, I think what you're doing now is you're changing your paradigms to make the Rust compiler happy, which allows you to write your program, but it doesn't necessarily make your program easier to understand. So I am not sure if that's a win overall.
I mean, this is one of the reasons that I avoid proc macro magic as much as I can. So even the proc macros that we use do one thing or try to do one thing and are relatively dumb, right? I try to generate as little Rust code from a proc macro as I can. and I try to stick to the trait. You know, if you derive something, it implements that trait, or at least that group of traits. So if you are making a language easier to write with lots of proc macros, are you really making it easier to understand or not? And that is, I think, one of the major choices in trying to smooth over the warts and notches of Rust with macro magic.
Sorry, I think another example of this is we've been trying to avoid things like ref counting, because ref counting is cumbersome to use and it leads to a lot of boilerplate. So instead, what we've been doing is move all our data to the top and then pass it along as a borrowed argument to the places where it's needed. But that also leads to pretty verbose code. So it's like no matter what you do, you end up with code that's less nice than what you would have had if we would have just had garbage collection or something similar.
Yeah, also it has evolved a lot. So the UI tree now is using ref counting and the data is borrowed. So if you do the UI tree borrowed and the data borrowed, you're going to have a tough time. But if you do the UI tree ref counted and the data borrowed, then at least one of the trees that you try to map to each other is disconnected from the borrow checker. And I do think, I don't know if you've looked at our recent code, I do think it really looks a lot better than it used to. So the complexity of the borrowed pass-through is much, much simpler because a lot of the logic can move to the top level.
Okay, great. Yeah, thanks very much. It's a very insightful points for sure. Okay, move on to another topic. So obviously all of y'all are developers who spend quite a lot of time dealing with the underlying platforms, the idiosyncrasies and little minutiae of each platform. Which platform do you feel like gets it the most right? Either in terms of their design decisions, the way they expose their APIs, what they allow and disallow. And as a follow-up to that, what would you like to see from a future platform that could do even more things right?
You mean operating system itself?
Sure. Yeah, or mobile platform SDKs.
I love Apple. It's great.
You love Apple?
Yeah,
okay.
late binding Objective-C is the single easiest platform that I can find. Metal code is simpler than any other platform. Yeah, if you look at Windows with COM is just a fixed vtable structure, but it contains everything that interface needs to have. Whereas Objective-C, it is late binding dispatch on a per method basis. And you can also implement interfaces often on a per method basis. So that means that you can completely minimize your interface layer with the OS. And you don't need headers, you don't need generated platform glue. So yeah, that would be my answer.
Yeah, I guess to add on to that, one thing that macOS does really well is that the API there's basically a fixed API. It's pretty stable. You don't have to look at a bunch of different places just from a practical perspective, to figure out how to do things. There's usually one way to do things. Maybe there's a high level and a low level way, but it's very straightforward. So I think if there was a new platform, if it took that approach and tried to get everything right from the beginning instead of redoing it 4, 5, 6, 7 times and then ending up with a hodgepodge, I think that would be excellent.
When you say get everything right,
yeah.
Could you expand upon that a little bit more?
Right. So, so I think when designing an API, it makes sense to think about how might this API change, even as simple things like naming the method calls in an API. Make sure they make sense for the future, and so that the next time you release a major version, you don't have to deprecate so much of it and have all your developers rewrite the code, or even make a whole new API that replaces the one that you made in the first place because you realized you did it in a way that doesn't make sense now. So I think Apple has done a really great job of that. The landscape for developers hasn't changed so much since the beginning of OS X.
So 2 votes for Apple then. Okay. Any other thoughts? Yes, no?
Oh, Apple, it's really next step, right, we're talking about here. This is the original next architecture of Objective-C and late binding. So when you're building a platform layer, even though as Rust we are early binding, you know, where everything is defined, all the traits are specified, everything is crystallized. If you're dealing with a platform layer, like for instance the web, or an OS that can change version or can evolve, actually the late fragmented binding is kind of easy, because you can just update it for the little fixes that you need when the platform updates. Yeah, so that I would say is a challenge for Rust, because the moment you change the API, people are going to have to change their code. Whereas if Apple adds a method to a delegate or an interface, nobody is going to notice, because it's all partially bound.
Okay, thanks very much. Next topic.
So I think most of you here know that there's a website which tracks the number of GUI-related crates written in Rust, and I just checked. There's actually currently 36, which I think went down a little. I think it used to be 40 or 50. I don't know. Anyways, it's 36. So what do you think a year from now that number is going to be? Is it going to be less or more? I know most of your systems are in that list as well. So do you see a trend of more people coming up with trying to write their own UI frameworks and app development frameworks, or do you see that sort of consolidating hopefully into mature systems that you guys are trying to help build?
Yeah, I think it's interesting. I mean, I quote that a lot, like 50, right? And they probably cleaned it up or put some in the archive. I think we're coming out of this experimentation phase. I hope we're coming out of it. And I think projects like MakePad and Diaxis and Tari are they're maturing to a point where if you're going to come out and build a new project today, it's kind of like frivolous pursuit, because there's just a mountain of work you have to climb to get to like the state of the art. So I think you're going to start to see some consolidation. Hopefully the number will go down. Mm-hmm. I mean, obviously people are putting out new stuff every day, which is good as like experimentation and learning. And we're definitely pulling features out of new libraries that come out, like Signals, for example. Our like original state management API was Signal-like, but now it's just Signals. So I don't know. I hope that number goes down. I hope like the projects that come out are like prototype experimental stuff that have the idea of being integrated with something that's mature. Mm-hmm. As we watch it evolve, I think that's probably the best thing for the health of the ecosystem in general. Like people getting on the same page and like backing each other rather than like fragmenting the ecosystem anymore. Right. Yeah.
Okay. Yeah. So. Yeah, a list like that is of course daunting, although as I've learned anything from UI and JavaScript is that everybody always wants to make a new framework. That's just how it is. But with React you do see that there's strong leaders in the field emerging that most people will default to. So for MakePad the main goal is that we get our visual designer in there, so you can drag and drop UIs back together and the IDE as an entry point for that stack. So I hope that that path, at least for MakePad, will be so easy that this sort of field of choices is sort of not that relevant anymore, because you start at a higher level of experience, right? You start at the level of here's an application you can drag and drop an application together with, instead of a list of names where you have to wade through lots of code and start at the code level. But yeah, if you can start at the design level with an application, I think that will change the playing field as well.
Anything else, Eddie? Or?
I pretty much agree that the mode here is pretty big. Like if you were to start a UI framework now, then the amount of work you need to do to even get feature parity with Diaxis or MakePad, that's huge. So I think it's unlikely that we'll see many attempts, unless maybe somebody figures out an approach that we haven't thought of yet that actually fits better with Rust. But yeah, that seems unlikely. But maybe I'm wrong.
Yeah, I mean, one of the things that I've noticed over the years is that some of the most popular or hyped frameworks has been from the large corporations, right? Started, I think, as early as Angular, probably even before then. Like I remember, probably 10 years ago, Angular was the hottest thing, and then at Angular 2 they changed it so that it's not backwards compatible, and then people all went to React, which is Facebook owned, and then So, Google seeing the success of React Native, release Flutter. So again, all these big corporations sort of controlling the most popular, most commonly used frameworks. So Rust currently, luckily maybe, hasn't had one of these big corporations standing behind one of their own framework. So do you foresee that continuing, or what if they do really something that out of the blue? And
So
then
I'm not too worried about it now because Rust isn't big enough yet. But there will be a point, I think, where that might happen. I kind of hope it does happen because that means, Rust will be successful.
Yeah, I agree with Eddie here. Like, the more the merrier in a way, because it is such a massive project. And that's also why I think people in the Rust ecosystem would do best to help each other as much as we can, because it is not really about the particular framework or use case. It's more about getting people to learn Rust. I think that is the big bottleneck for us all. So if a big corporation decides to do a UI framework for Rust and put essentially a lot of energy and money into teaching people Rust, that is going to be great for us all, because we're too tiny in that sense to carry that burden alone.
so I think that if some big company releases a Rust framework, that's a validation of the Rust language itself as well.
Yeah,
right?
it's a validation, and it's also a lot of extra energy that goes into building our ecosystem. So yeah, I would totally welcome that.
Right.
And I'd accept the challenge.
Great, yeah, it's always positive.
I think if, hopefully, one of these projects gets picked up by a big corporation. I mean, it doesn't have to be. I think you look at Vercel, Next.js, just community project, and they kind of have a huge decision-making power on the React team. They've hired a lot of the React team, so React is kind of under the thumb of Vercel at the moment. But I think if a Rust UI framework, GUI library, becomes the next hot thing, I think it comes from the community and then gets adopted by a big company looking to make a stride into the area, rather than a Google or a Facebook making that as their next big project.
Okay,
Yeah.
that makes sense. All right.
So on the topic of Rust, I wanted to address one of the the sharp edges of Rust, but not as bad as C. That would be unsafe code. I'm sure everyone here has had pretty significant experience dealing with unsafety. Be it touching the platform, touching the hardware. Can you talk a little bit about your experience dealing with unsafe code, and specifically maybe mention things that you would like to see improved about the experience of writing unsafe, maybe tools you could use, there's Miri, maybe some formal verification approaches, anything therein?
So one good thing about Rust is that when you have an issue with your memory, which is very recognizable, because the moment something breaks in a very unexpected way, you almost immediately know that you did something wrong with unsafe code. And if you're doing something in the application that you know is talking to certain APIs, and then it happens, then you also almost immediately know where that thing probably went wrong. So in C++, it's it could be anything, right? It could be your iterator or a thread somewhere. Anywhere in your C++ userland code is suspect. But with Rust, it is very, very contained. So I have almost never needed any special kind of tooling. I almost immediately knew where it was fishy or where it was wrong. Other than that, if it really fails, you can run it in LLDB, right? We're dealing with a lot of platform code that could also fail in different ways. So then you almost immediately know where it's wrong. So yeah, I would say it completely changed my idea of systems programming, because even the things you would think are hard, all of a sudden, because you use Rust, are just not anymore. Not to me, anyway.
So one thing I personally struggle with a little bit, and I think this is a known issue, is that currently Rust memory model is vaguely defined. For example, if I derive a pointer from a reference and I then write to that pointer, does that invalidate the reference or not? And I think the current understanding is that yes, it does, because the pointer conceptually borrows from a reference, and once you write mutably to a pointer that's derived from something else, then you should no longer be able to access that. So, I mean, this is being worked on, right? Like this is the whole stack borrow model and MIRI. But right now the rules are unclear. So I'm trying to write correct unsafe code whilst, well, the rules aren't actually clear. So I'm kind of forced to play fast and loose. I'm like, nah, this is probably mostly correct. But I feel uncomfortable doing that. And this is something I think could be improved, and that's being worked on.
So on that note, have you ever considered using additional tooling like verification or MIRI to help prove your mental model about why your unsafe code is sound? And if not, what are the potential barriers that you've faced that would discourage you from using this tooling?
I mean, this is mostly a matter of, I think we should do that, but because we have so much to do with MakePad, right? It's hard enough to write all this unsafe code to interact with all the platforms, and now it has to be correct too. So this is mostly a cost issue. I think we should do it eventually, right? If MakePad is ever going to be ready for commercial use, then we should use formal verification. And one of the things I have in mind is using MIRI for that.
We use informal verification called dogfooding it.
Yeah, so
you'll know if it crashes.
Well, but see, the problem with this is if you write code with undefined behavior, then most of the time it just happens to work. It works correctly, but if then the compiler decides to change some of its optimization algorithms, then suddenly your code doesn't work anymore because it was never guaranteed to work. I think that's a real issue. You don't want a situation where you end up with a security bug because of an LLVM update. So this is why thinking about undefined behavior matters, even if your code just happens to work.
From the perspective of the web platform, really our only tool is fuzzing. And without fuzzers, we would be completely lost, unsafe code or not. So that's what we have.
We have some microphone drift. So yeah, specifically for the web, just because the surface of the API surface, the entry surface of this is so large, I assume formal verification is just out of the picture. So I know that other similarly large works like GOSIM Time use fuzzing to great benefit. Is there anything from, on that note, is there anything from the Rust community that you think could help improve your fuzzing experience? And would you recommend fuzzing in general? Anything bad, good about it? Most folks aren't too familiar with fuzzing, so maybe we can talk a little bit.
Sure. I mean, one nice thing about fuzzing is that it's pretty implementation independent. If your program takes input, your fuzzer can be written in any language, and as long as it interfaces with your program, your fuzzer can generate random input, which your program generates. I can't really think of anything that would improve the experience, just because fuzzing is such an external thing to your implementation. But maybe I'm not sure, maybe, I really can't think of anything.
Yeah, no worries. So I know there are some fuzzing tools that strive to create properly structured input or input that stresses particular paths of the code. So I assume you're using those and you don't really have a want for anything else, something like that?
Yeah, that's true.
Yeah.
I mean, it is the case that some unit testing frameworks like QuickCheck are integrated at the Rust level. When you write a test with a QuickCheck type testing framework, that comes into play. I mean, maybe richer tools there would be more helpful. Things that you could tune maybe the input that you give your API. In general, they're pretty rich already, so I recommend using them.
So the takeaway is, yeah, fuzz.
Yes, never stop fuzzing.
Yeah, okay. Any other thoughts? If not, we'll move on.
I mean, yeah, we do some funny unsafe stuff in DiAccess. It's good. It works. It's how we wrestle with the APIs a little bit to get it the way it is. We do self-referential structures, bump allocators. We do fuzzing and we do MIRI. The one thing we run into is talking to system APIs. You can't push through MIRI. Tokyo you can't do timers, you can't do most FFI stuff. So kind of an open problem in the space right now is like, how do you interact with the system and also guarantee your stuff's still correct? There are like API paths in our code that are only hit with the like file system, and we can't fuzz or like test that in any way. So call for work there.
So going to a little non-technical side. So everyone is aware of obviously the AI revolution that's coming, and ChatGPT and code generation, Copilot. Do you have any advice for people that are sort of going into college or graduating from college, trying to decide a major? Is it still viable for them to continue with the computer science track and learn basic programming, or is that all going to be replaced in the next 5, 10 years, or even 3 to 5 years?
Can I take this one? So, personally, I'm not too worried. What I'm seeing mostly from LLMs right now is they're very good at generating code that's mostly correct, but code that's mostly correct is often catastrophically wrong. This is especially true for unsafe code. This is my personal experience from working with ChatGPT. So it's useful, for instance, to generate a quick mock-up of something, which I then can further develop. But I mean, at the end of the day, that means I'm still involved in the loop here. Like, there still needs to be a human to verify that this is actually correct, because the AI can't figure it out, and nor do I see that happening anytime soon. Like, I think it's inherent to the nature of LLMs that they generate the statistically most probable reply to something. They don't actually have any deep domain knowledge about what's unsafe code. I mean, even I don't know what's really valid unsafe code. So. I mean, and that's the other aspect of this, is that the AI is trained on code from humans, which is often full with subtle bugs like this. So obviously the AI is also going to learn these subtle bugs. So I think in the end, AIs are going to be very useful in the role of assistant. So things like code completion, or I don't know, one thing I was discussing with Rick earlier is where maybe you can do AI-assisted Git merges. That seems something that's very useful. But yeah, I am not worried about losing my job to AI. Rick may have a different opinion there.
So it's all about the time scales, right? If you say 10 years, I go, I have no idea. If you say 1 year, okay. So, but when you have to give advice to someone that has to spend 10 years in education, I honestly cannot say anything more than, pick something you find hard and fun and see what sticks for you. But in terms of job prospects, I cannot make any prediction at all beyond a certain range of more than 1 year. Because if you go back 1 year or 2 years, and you try to play AI virtual stock market without the knowledge that you had in those 2 years, I would have been wrong every single time.
Yeah. Can I add something? So one thing that I think is encouraging is when we got compilers, we kind of had the same issue. Like we have all these assembly programmers. Well, they're not going to be needed anymore because now we have compilers. What actually happened is, because we had compilers, this opened us this whole new range of things we could now write without us being overwhelmed by the complexity. And I believe something similar could happen with AI, where because we now have AI, we can offload part of the complexity to the AI, and this opens whole new problem areas that will require humans. So maybe the most likely thing to happen is that programming will become more high level than it was before.
Yeah, I have to say I agree with Rick. If it brings you joy, do it. I mean, you'll like it with the AIs, or you'll like it if they don't pan out. If you don't like it and you're going into it, it's not going to be fun either way. So maybe AI isn't the best measure of whether you should do it or not. Maybe it's, if you sit down in it, you're happy doing it, and you enjoy solving little puzzles, then do it for a job.
I mean, the stuff I see robots and AI not good at is picking strawberries and like folding T-shirts, right? These are hard problems for for any sort of automated system. And I think it'd be like rather crazy career advice to say, hey, to hedge your bets on like AI taking over software, you should probably get really good at folding laundry. Like, it just seems like a strange thing to tell people. Like, don't get into this space where people are building things because the tools of today might be obsolete in 10 years. I mean, programming languages come and go, systems come and go. Like, programming today might not exist in the same way in 10 years, but people will still be like wielding these tools to build things, and that's kind of what it is at the end of the day. I'm in it not to like write Rust, but to like build cool things. So I don't think we're gonna stop building things, and once we get AGI.
Okay, and so on a follow-up related to that, I mean, programming language is sort of like just a simplified interface for humans to make computer do something. So is there ever going to be the time where AI or system is smart enough that we can just use natural language for that task? Eliminate all the middle layer of the programming language it's translating from top to bottom.
I mean, you've seen Iron Man in the movie, right? Like, he doesn't write that much code. He tells Jarvis to do it, but he still like flies around and shoots lasers and stuff, right? So, if anything, I think we'll get closer to that. Then I don't think software's going away anytime soon. But if it does, at least it'll be like really cool.
You know, the problem I have with natural language interfaces is they're actually pretty low bandwidth. I can often do things faster with a mouse and a keyboard than I can do with natural language. Like I can see use cases for it, but I don't think we're gonna see a future where everything's done by talking to your computer. I just don't buy it.
Yeah, that's similarly, you have to draw things out in diagrams sometimes to get something across between programmers. And natural language is a very lossy way of describing anything. That's why we invented mathematics, to be more precise, because being precise is sometimes very important, especially in code and mathematics and models. What is difficult, though, is that we as humans have sort of lost our comprehension of the amount of compute that we already have, right? So if you take an image model and you run it on a state-of-the-art video card, it used to be that I kind of knew in my head how much computation a computer had, but because of the exponential growth of that computation, I felt that I've lost track of that at least 5 years ago or something, maybe a little bit longer, maybe 10, where I now have to have some kind of geometric model in my head of how fast that thing is. And I think there lies the danger in that, because we kind of lost track of how fast and how computationally powerful computers are, we cannot really think well with the modality changes that these massive computations have on what it can do, right? Like, I'm kind of in the know with computers, but I struggle to understand the vast computations just like a stable diffusion model does to get where it's going. It's pure magic.
I wonder if this is partially offset by, you know, the joke that like the biggest achievement of software developers is negating all the progress made by hardware developers. I mean, and that's kind of true, right? Like what happens is that software just becomes heavier because developer time is expensive. So yeah, we make all these compromises. Like, yeah, no, we'll just allocate a lot of memory here because it's cheap, and yeah.
Yeah, and AI is absolutely the worst way to generate certain things. I think people are going to go like, oh, we can use AI for this regular expression, and then they're burning 300 watts on a 5 words per second regular expression, essentially. So we're definitely going to see a whole bunch of fun like that. But
All right, well, we only have a few minutes remaining, so I wanted to offer the audience the chance to ask any questions. Doesn't even have to be related to Rust or app developments or mobile web. Does anybody have any topics they'd like to hear us discuss, or any interesting questions to raise? All 8 of you? No? Yeah. Wait.
Do you guys see a place for something like Rust script, where we take, I don't know, we add a GC by default, use Rust syntax, and maybe even be able to compile it eventually to Rust executables?
My counter question would
Maybe
be,
relax semantics on maybe move checks from compile time to runtime.
my counter question would be why? Because like I think if you were trying to turn Rust into a scripting language like JavaScript, like you would kind of get the worst of both worlds. Because like one of Rust's greatest strength is that it's strongly typed. Most script languages are dynamically typed because you want that flexibility. Like I feel like these are competing goals, right? Like, do you want a language that's statically typed and compiles to native and is as efficient as possible whilst still being safe, or do you want something that's flexible, dynamic, uses a GC? Because in that case, like, why would I still want to use Rust at that point?
Actually, I think it could be very interesting in education, teaching people how to program. You see this sort of in JavaScript, where JavaScript was a very popular language, very popular first language. And people usually learn JavaScript, and then they learn TypeScript. And they are introduced gradually to the concept of types and the idea of type safety. And maybe instead of Rust being this language that you learn once you have reached the top of the echelons of computer science, maybe you could be introduced to it gradually. And then only finally do you defeat the final boss of the borrow checker and take your place among the Rust sea.
I think it also ties into what Josh said during his keynote, making it like more accessible to people, to allow them to run their Rust code even if there are still things wrong. Let them see what it looks like, do early prototyping, or for instance what Rick earlier said, allow them like the first hour when you're prototyping something or investigating into a new area. All this is quite valuable, and people choose other languages currently because it's really hard in Rust to do.
Yeah, so one hope that I have is that we don't really have very strong numbers on what happens if you teach people Rust first, right? So we're kind of dealing with the shock of a lot of JavaScript developers now having to deal with Rust. But I have seen people try to learn JavaScript, and the dynamics of the language were a major frustration in trying to understand what it's doing. So it is possible that for a next generation, starting with a very strongly typed, very strict language might actually help the learning process. And we're just dealing with the legacy of too many years of weakly typed dynamic languages having to be unlearned.
I think Rick makes a very good point there. Back when I was in university, we learned both high-level and low-level languages. And I recall that what made C so hard was pointers. Like C itself is not a very hard language. It's pointers that makes everything complex. Now, well, for most Rust code, you don't really use pointers, right? Like only on safe Rust uses pointers. You have references. And references, I think, are strictly less complex than working with pointers because they have better defined semantics. Like, I think we find Rust borrow checker frustrating mostly because we come from either JavaScript or C++ background, so all the patterns we already learned no longer work. But what if you start? What if Rust is your first language and you don't have those patterns yet?
Yeah, or all the intricacies of how JavaScript automatically tries to convert an object into a number. I mean, everybody knows the jokes on the internet, how fuzzy type conversion leads to the biggest, idiotic bugs and beginners going, what is this? Why are we learning this? We don't. This is madness.
Not a number is not a number, right?
Yeah. Well, so in Rust, a lot of these cases are very elegantly handled, especially in relation to types, so that when you're not allowed to do something, actually that is important to know, and instead of like fuzzing it with magic of actually breaking in unexpected ways, the compiler will tell you in very nice words why is not allowed what you're trying to do, and that might actually benefit new learners.
The compiler is actually a great learning tool for Rust. I agree.
I have a different answer. Wildly different. Nothing to do with programming languages, honestly. There's like a culture in Rust. Cargo, Rust doc, like the errors, like I think a lot of the reasons why people like Rust have nothing to do with the language and more just to do with like the tooling built around the language. Like Rust was supposed to be systems programming, but we're up here trying to wield it as like an application, like programming environment. And like Swift does a very good job at that, and TypeScript do very good jobs at that, right? Like TypeScript or Swift is basically Rust with a garbage collector. It's good, but like people aren't really using it outside of the domain for building apps because that's just not Apple's focus. Whereas like Rust, everyone's trying to wield it for whatever, like embedded to backends to front ends to rendering stacks, right? So there's like a culture of like do anything, and I think it comes down to like the package manager is good. It's a community-driven project. It had like it's not really like a Google project or an Apple project, and I think when people say can we have Rust script, I think what they're really saying is can we have everything that makes Rust good but just a different programming language? Like it comes down to like enums and package manager, right? Like that's what everybody wants. I think if you could get all the benefits of Rust without having to deal with lifetimes, you would just do that. But we're here wielding a language that is rather difficult for a lot of the purposes we put it through because everything else is just so good.
Yeah. I mean, what I really want is this JavaScript with enums.
Yeah. Yeah.
Okay, we're coming up at the end of our time here. Any final thoughts? Questions from the audience? No? Okay, great. Well, I'd like to thank all of our panelists very much for spending another hour with us and giving their unabated thoughts about Rust in the community. And thanks to the small but mighty audience for sticking with us until 6 p.m. on another long conference day. So yeah, round of applause for everyone. Thanks so much for attending the GOSIM conference. I hope you guys all had a great time, and there will be more KubeCon festivities for the next couple of days, so stick around for those if you're so inclined. Otherwise, have fun in Shanghai. All right.